So hi, my name's Jason, and I want to talk today about testing. And specifically, I want to talk about convincing teams to test. So by a quick show of hands, let's start with some participation. How does everybody feel? How many teams here are already very well tested and very comfortable with your testing workflow? That is a lot more hands than I expected to see, I'm not gonna lie. For the rest of us, so we all know that testing is very important. There's no question about that. That's why we're here. We know that well-tested code bases make our jobs easier, it makes our products better. There's no dispute about that. But fewer than half the hands in this room went up, and I would say that we're the most motivated people, arguably, on the planet, considering we showed up to a testing conference about testing, right? So despite the fact that we all know that, we're all super motivated, why isn't testing in place? Why aren't we all sitting on incredibly well-tested apps? That's what I want to talk about today, and I want to talk about how we rolled out testing strategies to IBM, which IBM, for those of you who haven't heard of it, is a large-ish company. We employ about 400,000 people, and those people are distributed across products around the world. I think we've got offices on every continent except Antarctica. We might even have something on a research vessel out there, I have no idea. But we had to figure out, how do we get teams distributed from China to Austin, Texas, to Toronto, to California? How do we get, and we've got teams in Germany and everywhere, Italy. How do we get all of those teams to agree and follow a testing practice? This is not a small task. So the first thing that happened was we started getting a lot of reasons why it wasn't possible, why it wasn't happening already. And some of these hopefully are going to sound familiar to you, because otherwise this is going to be a really confusing talk. The first thing that we heard is we don't have time to write tests. And this was by far the most common complaint that we heard. We don't have time to do this. We heard people say things like, we don't even know where to start. We've never written tests. We don't know what Mocha or Jasmine, like that stuff doesn't make sense to us. They'd say things like, testing slows us down. It keeps us from hitting our deadlines. And at a company like IBM and most larger companies, feature-driven development, unfortunately, is a reality. We would hear that tests were too hard to maintain, and this is a very fair point. And I think that a lot of people, I know for sure that Kent Dodds is going to be talking about this today, are going to be talking about how to make tests easier to maintain. Junior devs don't know how to write tests. This argument drives me crazy. Your job as a senior dev is to make the junior devs good at things. So I hate that argument. This one is a little more valid. We don't have the bandwidth to train them. I understand that. I've been on tight deadlines and been told that we needed to deliver something. You don't have time to sit and do workshops with the whole team and also deliver the features you're on the hook for. So I get that. But mostly it just kind of comes down to this. Like, oh, but it's hard, I don't want to write tests. The fact of the matter is, and we all know this, hard or not, we need to be writing tests. There's no option here. Testable code is a requirement if we're going to be writing production quality apps that are going to go out to large audiences. Because if we're not writing code with tests, we're just making educated guesses. We're looking at our code and going, yeah, that's probably going to work, and let's ship it. That's fine if you're writing a tiny code base and you're the only developer. But as soon as you scale up to 2 people, there's now context that is not shared between your head and theirs. When you scale up to a team of, 700 people, like my team at IBM Cloud, there is no way in hell that I know even a tenth of what's going on in our code base. It has to be tested, or else I'm just shipping code and crossing my fingers and hoping nothing explodes. And if you're just guessing, this is where the 4 a.m. page comes. This is where I find out on Sunday morning that I broke something, and now, instead of doing whatever it was I thought I was going to do this weekend, I get to fix that. So even smaller code bases are going to have a lot of edge cases. You look at little utility libraries that have 500-600 lines of code, you can still find ways to break those. If you put in weird data inputs, if you somebody does something silly like serialize a JSON object so they can send it as a string, it's going to explode. You're going to have problems. People will find ways to break it. You need to be testing for these. And manual quality assurance, if it's happening in the first place, I don't know how your company works, but at IBM, manual quality assurance is like, I don't know, send the link around to a few people and hope they actually click on them. If you don't have, like, even if you do have a good manual quality assurance process, that QA process is not going to catch all the edges. You don't have time. On a sufficiently large code base, there is absolutely no chance that you can go through the full checklist for every single PR that gets shipped into production. It's just not feasible. The amount of time required would be completely unreasonable. And so this all leads to the fact that testing isn't really optional. It's something that we have to be doing. And the great news is that testing does not have to be hard. We can write tests that are easy to write, that make our jobs easier, that make us better developers. All of that is possible. And the only thing we have to go through is coming up with the upfront time to to put it in place. So I'm going to start by just kind of sharing with you the way that we made this work at IBM. So this is what I'm going to call a battle-tested strategy because we've been running it at scale across multiple teams distributed around the world, and it's been successful. And it's not bulletproof, and it's not perfect, and a lot of our code is still like 3% covered, so I'm not going to claim that we've got this figured out. But what we have seen is multiple products have gone from no coverage or very little coverage to well above the 80% coverage threshold. Many of the projects that were regularly receiving 4 a.m. pages on weekends have not been paged since we implemented this strategy. So it's not perfect, but it's going to work. It's going to help. It's going to improve things. The first thing that we did is we removed everybody's ability to commit directly to the code base. You have to send a pull request. For those of you who are nodding your heads like, duh, I'm glad that you're thinking that. For those of you who are going, what the hell's a pull request? This is a talk for you. Once we get that pull request in, we've got a build pipeline, something like Travis, Circle CI, Jenkins. Across IBM, we use both Travis and Jenkins, depending on the team's taste. In that pipeline, the code needs to meet our testing requirements, it needs to meet our quality guidelines, and we need to make sure that all changes are peer-reviewed and approved before they merge. So you can't merge your own pull request. You have to pass all of our guidelines, and then someone else has to say, yep, I agree, and then they merge the code. Right? So there's a lot of reasons for this, but first let's talk about the testing requirements, because that's kind of a squishy term. What is a testing requirement? Ours are loose. First, the app needs to build successfully. We run a node microservice architecture at IBM Cloud, so everything that we do, we have to install our node packages, we have to run the build step. We need to make sure that that works, right? So that's kind of like table stakes. All of the tests that exist need to pass. That's also table stakes. You can't break a test and ship it to production. Any new code that we ship has to meet our coverage thresholds. You need to have testing in place for any new code that you've written. And maybe, depending on the code base that you're working on, we want to make sure that your coverage threshold is met for the entire repo. This is going to have to be done on a repo by repo basis, because if you're walking into a 500,000 line piece of legacy code and it's got 3% coverage, it is not reasonable to expect that the first person to submit a pull request needs to get that up to 80% coverage. It's never going to happen. So depending on what state the code is in when you implement this process, you might just be setting the coverage thresholds for new code. And if that's the case, that's fine. You should be aiming toward getting the whole repo up to speed and more functional, or more covered, but baby steps, right? Quality guidelines, another squishy term, so let's talk about what those are. I'm about to throw some jargon around. Stick with me, I'll explain it. The first one is you want to limit your cyclomatic and cognitive complexity. This is a fancy way of saying write easy to read code. Not a bunch of nested loops, not 300-line functions, things like that. And there's ways to check this through ESLint and other linting tools. They just look to see, oh, you've got 5 nested for loops. That's too much. That is too many nested for loops. Rewrite this. We also want to avoid known problematic patterns, things like using the double equals instead of a strict equals, things that are going to cause problems in your code base eventually. We want to catch those ahead of time. Just have a check in place that makes sure that they work. Check for any security vulnerabilities. You can use things like there's a tool called snick.io and a lot of comparable services that are just going to do checks and say, hey, you just installed a package that's going to let everybody who wants to DDoS your app. You should probably fix that. And then we want to eliminate duplicate code. And there are a lot of reasons that you might want to duplicate code, but as a default, you probably want to check for duplicate code and see if it could be pulled out into a utility function or something that's going to make your life a little bit easier. One huge caveat, we should not ever be failing pull requests on style. If you haven't installed Prettier yet, just do it. I mean, just like, yes, it's going to tell you how to write your code. It's going to force you to use semicolons. It's going to force you to do weird wrapping for ternary operators. Some of it's really annoying. But I'll tell you what, the amount of mental freedom that occurred when I finally installed Prettier in my code bases and just stopped thinking about it, I feel like it's what people must feel like when somebody who's never walked before stands up and they're like, oh my God, this is amazing. If you are wasting time fighting about things like tabs versus spaces, you don't have the mental capacity left to have a discussion about quality code. Tabs versus spaces has no impact on the quality of your code base. Talking about something more in depth, oh, well, you could make this functional and eliminate these side effects, having that discussion, maybe that is a more valuable discussion. And if you waste all your mental energy squabbling over style, it's just not worth it. Just install Prettier, please. The great news here is that our tests and quality checks can be automated. Almost everything that we're doing at IBM runs on an automated process. So we've got linters and IDE plugins so that as you're writing code, we'll give you a red squiggly line and say, hey, that's too many for loops. Or things like Prettier, as you save, will automatically reformat code so that you never even have to check in something that would cause a problem. Husky and Git hooks, as you try to push to one of our Git repos, we're going to run the test suite for you so that if you accidentally broke a test, we'll tell you that before you open a pull request. We want to limit the feedback loop to the shortest possible time. And for those of you who haven't used Husky, Husky is an NPM package that gives you access to the Git lifecycle so that you can put hooks into your package.json, things like pre-commit, pre-push, that kind of stuff. It's really, really, really useful. Travis, Jenkins, Circle CI, you can use any of those to build the PRs. As soon as you open that PR, the pipeline is going to recognize it, grab it, and run your build process. Once you've got a template for how these processes work, it's pretty easy to just copy paste it across to all your other projects. So you don't need to, this isn't going to be a lot of investment in an ongoing fashion. It's just an investment in the initial step, right? You just have to get it set up, and then it's pretty easy after that. Tools like Sonar Cloud, Code Climate, Codicy are going to give you real-time feedback on the quality of your code. They're going to catch those cyclomatic complexity and all, the known bad patterns. They're going to catch that for you. I didn't write it down, but snick.io will hook right into your Git pull request workflow. All of these things, once you set them up, they're now out of your head. Nobody has to watch this stuff. It just happens. You can even put in your build pipeline a step to have Prettier run and just commit the fixed code so that the style issues just go away. And there are a lot of reasons why this strategy works, and I've already talked about some of them, the biggest one probably being that it's automated. But what we've seen is that pull requests, they will create a control flow. And that control flow is designed so that we don't have people just pushing to master or force pushing to master, right? And if you're fortunate enough to be on a team that hasn't had problems with somebody force pushing to master, I'm super jealous. But so, we want to eliminate things like force pushing. We want to create that place for the automated test to run. If you're just pushing to master, the automated test will run, master will build. But if it fails, that code is still in master, right? So you can introduce problems, and even if your pipeline is working, it doesn't roll back the changes. So the pull request allows you to make sure that code is meeting all of your set guidelines before it goes in and screws up everybody else's day. Requiring team participation is something that I think, as developers, I think a lot of us have a kind of superhero complex. We think that we should be able to work in a vacuum, that when we're writing code, when we're coming up with solutions, that if we come up with a solution that solves the problem for us, that is good enough, and we can stop there. Unfortunately, that's not the case when you work on a team, especially if you're working on something like open source, because other people need to maintain this code. Other people need to understand what's going on. Having a pull request workflow means that at least one other person on the team is going to be looking at what you did, and if you did something confusing, if you've got one-letter variable names or something, they can go, hey, I don't understand what you did here, and you should refactor until they do. This is one of those things that as a like high output developer, it's going to feel like slowing down. It's going to feel like, putting on like cement shoes or something because you can't just whip through code. But over time, as you improve your habits, as you start writing code by default that's more understandable to other developers, you're going to see the ability of your team to perform at your level. It's going to just soar. Like you'll never believe how productive a team can be until you all understand each other's code. That's where you really you get moving. By putting automated tests in place, you're going to have the ability to catch those regressions before they get shipped to production. I mentioned this before. Since we put this testing pipeline in place, any team that has fully embraced it has stopped getting paged in the middle of the night. We use PagerDuty to check for any severity 1 escalations, something broke, somebody can't get into their account. Those have stopped happening because we have all of our critical work paths, all the happy paths for the user are covered. We know that they should be working, and our test pipeline is going to go through those steps and make sure, yes, our users can log in. Yes, our users can click these buttons and get to the pages that they need to go. Yes, we know that this data managing function gets the correct results because it's written in a way that we can guarantee that the same inputs always give us the same outputs. All of those types of things have meant that we don't have that level of unpredictability that makes PagerDuty a big problem for people. Putting quality checks in place is also going to minimize your technical debt and maintenance overhead. Again, by having those checks there so that when you go to your code base and you make a change, the tests are going to tell you, oh, you accidentally broke this thing that you thought was unrelated. And in a sufficiently large code base, accidentally breaking unrelated things is like 80% of what we do as developers. So we need to have tests in place to let us know that we fixed something. One of the teams that's always impressed me about this is Facebook, and Google does it as well, where their code base is set up and instrumented well enough that if a team breaks code, other teams, their code will also notify back, hey, you broke our code. And I think Google is the team that has it in place where if a team at Google breaks somebody else's code, they either need to refactor their own changes so that it no longer breaks that code, or they need to go commit a pull request to the other team's code so that all tests pass before they can put something in. That's a really powerful idea. IBM, right now where we're at, that is so far from possible that it's kind of laughable. And if you're on a team that's small enough that you can still do that to your code base, do it now. Because retrofitting that when you've got a team of 500 developers is going to be hard, if not bordering on impossible. So do it quickly while you've got 10, 20, 30, 50 developers. It's still manageable at that point. You can do a hackathon to try to figure out ways to instrument across the code and put those integration and end-to-end tests together that'll catch those cases. The other thing too, and this is probably my favorite reason to automate, everybody hates the pedant in the office. Nobody wants somebody to just slide in from out of the cubicle and be like, actually. So you want that to be done by a robot. And there are a few reasons for this. The biggest reason, and I say it as a joke, but honestly I think this is the most important thing. People will feel persecuted if you pick on their code. A lot of us tend to take it personally when we get feedback on our work, and we tie the output that we're creating to our personal value. The value we produce for the product is our value as a human. So if somebody is constantly telling us that we made mistakes, that is going to, it's hard, it hurts, right? But if you make it something that's a blanket process that's performed exactly the same way for everybody, then it stops being a personal attack and it starts being like a stoplight, right? I don't feel personally attacked when a stoplight tells me I can't cross the street. And so if my code quality checks tell me that I can't check in 18 nested for loops, I don't feel personally attacked. That's not like Samantha being a dick. That's the code robot saying, hey, this isn't allowed. Like, we as a team have decided that this is not a thing that we can do. And so it takes the personal attack out of it. It makes it a very measured thing. The other thing too is the consistency of this review is gonna be much higher. So if you're reviewing code for somebody who you trust, you're not gonna put the level of detail into it, right? So somebody who is like kind of the company rock star, who's very well known for committing good code, they're gonna be able to commit more crap than a junior developer, right? Because everybody trusts the rock star, and so the rock star is gonna get a lot of like looks good to me reviews, and those are just gonna go in. And the junior developer is going to get picked on, and they're going to feel personally attacked or persecuted in the office because, well, why doesn't this person always get like the same level of detail applied to their stuff? Remove that process altogether. Make it a robot. Make it something that's completely impersonal, completely impartial, so that it's the exact same code review every single time. Everybody's on the same playing field. And I didn't write this down, but if you're using GitHub, my absolute favorite feature of GitHub is the include administrators checkbox. Everyone needs to be on the same playing field. If I own the repo, I also need a PR review before I can merge my code. And if that's not the case, you've set up an uneven playing field, and again, you've got that potential problem where it starts to feel like some people have privilege and some people don't. It needs to be flat. And again, this isn't like style review. This is we have decided as a team that these are things that are bad for code. So it's not picking on you, it's just saying, we've got standards and you're not meeting those standards, please adjust. Another thing that I really love about the PR workflow is that peer reviews are a great opportunity to share and for other people to learn. So we have our junior devs review our senior devs PRs. We do a two-person PR process. The junior devs review first, and a senior dev finishes up. And the reason that we do it is actually so that, like, if I commit a pull request as a senior dev, our junior devs review it and they go, oh, I didn't know you could do that. That's super cool. Or like, I don't understand what's happening here. Can you explain this to me? And we get a chance then to kind of like, in the moment, coach them on better development practice. And then by having a senior dev review it, we make sure that nothing actually slips in that shouldn't have. But it's a great way for everyone to kind of cross-pollinate, to share that knowledge. And a senior dev reviewing a senior dev means that, like, maybe I just learned some crazy little optimization that blew my mind, and so I can share that with one of our other senior devs, who will then share it with all the junior devs they work with. It's a great way to get that information out there, because not everybody has time for lunch and learn, you know? And not everybody's gonna go and read like the insane fire hose of information on Twitter from all these brilliant people who are solving these problems, right? I can barely keep up with like just Dan Abramov, so I can't. So having that opportunity to do it on the company's dime as part of your regular workflow is a great way to make sure that your team is progressing and becoming better. Testable code overall is just better code, and I say that with zero reservations. If you are writing code and you have to refactor something to make it more testable, I will say that in just about every case, probably every case, you are making better code. And there are a few reasons for that. Probably the biggest one is you get cleaner separation of different functionality. What I mean by that is, before I started writing testable code, I would do things like write a function that had 3 steps, right? And it's not a long function, maybe it's only like 15, 20 lines of code, but those individual 3 steps are difficult to test, right? And sometimes you want that. Like sometimes you do want just a function that gets you an output, it's very declarative, you don't really care what happens in the middle. But in other cases, like loading data, parsing data, and outputting data are 3 pretty distinct steps that you probably want to test thoroughly, right? So maybe you should break that into 3 different functions so that you can test them in isolation, right? These are things that you start doing when you start writing code with testing in mind. That's a very high value thing that you can do, and it's going to build better habits. Later on, when you're writing code, maybe you don't even need to write tests, maybe it's a prototype, you're still going to write cleaner code, it's still going to come out better. You're also going to end up with fewer side effects because writing mocks is probably the worst thing about testing. When you have to write up a test, and every test in your code base requires you to mock like an Ajax layer, it requires you to mock out like the entire Express package, like this stuff is a nightmare, right? So instead, you start writing these like small functional pieces of code and you push all the side effects to the edges. I feel like that's a buzz phrase that I've heard a lot, which is like push the side effects to the edges. You want to have the smallest possible surface area of tests that need mocks. Almost everything in the code base should be functional. I know this is me asserting opinion. Like you can tell me I'm wrong. Find me in the hallway afterwards. Let's not do it here. But the idea of making your code base mostly functional or mostly pure, where like you put in an argument and the same result comes out every time, that is going to make your life so much easier when you're testing. It's also going to make your life easier when you're explaining this code base to other people. It's also going to make your life easier when you have to revisit this code base in 9 months and you haven't thought about it. Like all of those things, not having to remember that, oh yeah, so this class is using a singleton pattern in this file which holds state, and then that can be affected by this. We're not living in the matrix. We can't look at this code and just like understand what's going on, right? So making it simpler, giving all of the code a smaller footprint is going to make your life easier. You also end up with better APIs because you're just testing for it. When you write unit tests for a key piece of business logic, you're going to end up throwing garbage at it. You're going to serialize that JSON object and pass it in as a string just to see if you can. And when you put that garbage through, you're going to find edge cases that otherwise your customers would find in production. And by doing that, you're going to then refactor your API to catch some of those edge cases. Or you might find perfectly legitimate reasons that just don't make sense with the API you've designed. And then you're going to refactor for those. So your API surface ends up being more resilient, more reliable and stable because you've thought through how people might break it. And there are also things, I forget the name of them all because I don't actively work on these, but they're testing libraries that just like throw chaos at your APIs to try to break them. Use those, see what happens. So at this point, I've made a big case that you probably already knew, which is the testing is important. I've talked through the IBM workflow, how we're getting people to adopt this workflow, but I haven't talked about what was probably the hardest part, which is how do we actually get there? Like what is the step, the action steps between, okay, we want this and it's done? So this is probably like the meat of my talk. This is the part that if you nod it off, now's the time to perk up. Let's pay attention here because this is the part that I think will actually be useful. The most important thing I've ever learned as a developer is that you have to make the right thing the easy thing. When you are looking at shaping any process, when you're looking at coaching anybody, writing docs, giving a workshop, designing a process or an API, you have to assume that everybody there is the laziest person on the planet. And the reason I say that is because eventually we all are. When you're looking at an API, when we start, most of us are going to be excited and we're going to want to do it the right way and we're going to read all the docs and we're going to do all the right things. But eventually it's not exciting anymore. It's just what we do for a living. And we're going to find the fast way to get the result because we want to go to lunch. Like, I don't want to have to spend a bunch of time working around these weird inconsistencies in the API. I'm going to do the easiest, fastest thing so that I can be over it. And we, as the people designing these systems, need to think about that. And we need to make sure that the default action, the thing that is the path of least resistance, needs to be the right thing. It needs to be the thing that we want developers to do. So when we're designing a testing workflow, we need to be thinking through, what is the workflow now? Why is everybody suffering? What is painful? How can we explain this and design this so that by doing the thing that we want, you're eliminating more pain than you're experiencing, right? Yes, writing tests is a pain in the ass. Getting paged at 4 in the morning on Sunday is way worse, right? So you have to shape it around those ideas, and you also need to make sure that like testing is hard to get started with. If you're a junior developer, or we have some people who are kind of bordering up on retirement, they've never had to write tests, it was just never part of what they did. That's scary. Like if you're an older dev, you're probably always like somewhat concerned that you're going to just get nudged out of the industry, especially with technology changing quickly and JavaScript is a new framework every week. Like, there are a lot of things that can make you feel like you're at risk of becoming obsolete. And so if, in addition to having to keep up with the latest in JavaScript, you're also now asked to learn this entirely new skill set of testing, that is scary, and it's going to cause some resistance. So we need to make sure that we're shaping this so that it's easier than what was happening before. We want to make sure that everybody feels like they're on the bus. It's not, hey, I'm the hotshot architect, I'm going to come in and tell y'all how to do your job, and if you don't do it, you're fired. It's going to fail. Everyone's going to rebel. You're going to have a straight up mutiny on your hands, right? So you have to make sure that you're thinking about it as a way to say, hey, everybody, I want your life to be easy. I understand your pain. Here are the reasons that this sucks for you, and here are the ways that I'm addressing those problems with this new design so that your life is going to be actively improved. Come along with me. Let's make this happen. So here are a couple things that you could do. We integrate these checks right into our workflow. So when you submit a pull request, this one shows Code Climate and Circle CI running. I pulled this off the Code Climate marketing page, but basically what it's doing is it's saying, as soon as that PR gets opened, we're going to run Circle CI and Code Climate, and all of those tests have to pass before you can even attempt to merge the PR. And this is really useful, right? And that Code Climate, I believe Code Climate will just add comments in line that say, hey, this is the problem, here's a link to solve that problem, and like once you've fixed it, push up a pull request and we'll rerun this check and then you can merge your PR. Another thing you can do is take advantage of the fact that most of these quality checking tools, and this, you can't read this, I didn't want you to read it, it's just a link to a description of how to fix an issue. So when you get a flag from something like Code Climate or Codacy, they're going to give you a link that says, this has a cyclomatic complexity of 15, your expected limit is 5. That doesn't mean a lot, but if you click the link, it's going to show you something like this that'll give you an example of the bad pattern and an example of the good pattern and an explanation of why it's important. This removes cognitive load, or not cognitive load, but just time load on the senior devs, because when somebody who's never heard of cyclomatic complexity, which was me 9 months ago, that not having this link means that somebody in the company needs to make time to explain that. So take advantage of this and really lean on the fact that like a lot of this work has been done for you. This is a built-in coach for most of the team. So you as a senior developer might have to swallow your pride and say, okay, I'm going to do it the Code Climate way so that I don't have to write my own set of docs, right? Use the tools that exist. Another thing that's really important is try to make the learning curve as shallow as possible. One of the gripes that I have with a lot of testing is that in order to get started, it feels like I have to install and understand 3 to 7 packages, right? So this is, and I'm not specifically picking on Mocha Chai. It's a problem in a lot of testing frameworks. This is just the first example I came up with. In order to use it, we've got to have Mocha running. You have to include Chai. You have to include sign-on. And then you have to understand the API of each of these to write this test. And when I have a question, I'm not sure if I need to search the Mocha docs, the Chai docs, or the sign-on docs, right? All of these might solve my problem. Several of them have like duplicate solutions, like one solves it this way and one solves it the other way. I'm not sure where to go. And if I'm a junior dev or somebody who's got very limited experience with testing, this is daunting, So one of the ways that we can limit this, if you don't have testing in place already, is to look for a solution like, this is Jest, there's one API, there's one set of docs. So this is the similar solution that only requires Jest. And in doing this, we don't have to include a bunch of packages. And if we have a question about how to do something, we go to Jest and we search for that. It's a small thing, but this, like having to look through 3 sets of docs for an answer is cognitive overhead. And it's expensive. It makes you tired and it makes you not want to do it. So being able to go to an all-in-one API, another great solution for this is Cypress. I think that we're going to hear from them later today. They've done this for like integration and end-to-end testing. It's an all-in-one API that solves most of the problems. So look at solutions like that. If you don't already have testing in place, I'm not saying that if you already have a lot of your code written in Mocha, that you should go and rip it all out and put Jest in. It's probably not worth the effort. But if you don't have testing and you need to train a new team, consider something like this that has everything in one place. Another thing that was really important to realize for us, starting from zero is really, really, really hard. One of the hardest things to do if you are a writer, for example, is to look at a blank sheet of paper and create a story, right? So that's why we get things like writing prompts. And as developers, getting a piece of code and saying, all right, you got 0% tests, test it. It's the same kind of thing. It's a blank sheet of paper. So instead, why not create testing prompts? At IBM, what we've done is because we're a node microservice architecture, we end up having a lot of boilerplate. There's a kind of like a harness that most of our apps sit in that allows them to hook into our overall architecture. When we ship that harness boilerplate, it comes with all of the actual boilerplate tested. And we do that because I don't want you to have to rip out a bunch of like demo tests, because that's silly, like, I shouldn't be giving you a chore. But I also want you to be starting with like 95% coverage. That's a really easy thing for us to do as the team that's rolling out these processes. We built the boilerplate. We should have tested it in the first place, so why not just build that into the boilerplate? So now when somebody starts, they're starting with tested code. And taking tested code and keeping it tested is much easier. If you start somebody at, like, they're winning, and you say all you have to do is not fuck it up. That's like the whole goal. And instead of saying like, all right, we have no support for you, you are starting at 0, and if you don't deliver this by the end of Q1, it's going to go into your performance review. Like that's, you're starting somebody at a deficit. You're starting somebody set out for failure. So, we want to make sure that we're giving people the best chance to succeed. And so, if you have the opportunity, if you've got internal boilerplates, start them out tested. Internal training is also going to be really critical, especially if you've got a larger team, especially if you've got a lot of people who aren't particularly familiar with testing, and also if you've got a lot of people who came from different companies who are differently familiar with testing. You want to be on the same page. A big problem that we have at IBM, because we have so many developers, is that one team is using Mocha, one team is using Jasmine, one team is using Jest, one team is using Ava. We have really hard challenges to overcome because everybody likes their solution. So it's important in the company to do this internal training and get past what you like and get to what you can use. What can everybody actually participate in? That's an important question and discussion to have, because it doesn't matter what I like. If I had my druthers, I'd have a very particular stack, but that's not what I'm here to do. I'm here to make sure that the whole team, that everybody in IBM Cloud is able to work on a set of code. So that is like, think beyond your own preference. Think to what's going to solve the problem for everyone. One of the ways that you can do this is to hold some hackathons. If you need to get old code tested, set up maybe a day per sprint or half a day per sprint to get everybody in, and everyone's going to write one test, right? Just one test. And over time, those tests are going to add up to good coverage. You're going to have some of your edges covered. And it's a slow roll, but it's also not a big ask. Spending 4 hours once every 2 weeks to work on testing is something that you can fit into sprint planning. It's something that you can fit into a deadline-driven development without interrupting the ability to get that feature shipped. You can also do, if you've got more time, full hands-on workshops. In IBM, we do something called Feducation, which is an hour every couple of weeks. Every week in our local branches, we do something that we call Fed Date, where everybody gets together and we do a hands-on workshop to learn something. So, we've got 1 week we'll learn Gatsby, 1 week we'll learn how to write like a Webpack config, stuff that, so it's just something that somebody in the community is learning. They come and share it, and we've done it with testing. So it's a way to get people together and have them learn how to do something. One of the ones that is really, really hard to do, but that is extraordinarily beneficial, is trying to get cross-team code reviews in place. If you can get it to where on a semi-regular basis, maybe monthly, You set aside a couple hours and teams will just kind of look at code. And a caveat on this, when you're doing code reviews, I talk about code reviews and I think a lot of people hear that as like, oh, well, let's find the problems and talk about how to make them not problems. Yes, but also, you should be working to find good examples. Here's a great way to solve this problem. So-and-so did it, it's excellent work, let's talk about why. You know, code reviews can sometimes feel like the like public square shaming hour, where you're going to pull the whole team together and you're going to drag somebody out in front and be like, hey, you wrote shitty code, let's like make fun of you and talk about all the ways you suck at code. So you have to balance that. It can't feel like, oh no, code review, I hope they don't call on me. Like, you want to get called on. Like, half the time it's going to be good news. So I think that that's a really important thing to consider is, you know, do code reviews, but make sure that you're calling out the good. Like, this is a really clever way to solve this problem. You know, we reduced the complexity of this function, or, you know, we removed it from like ON to O1. Like, this is great, let's make this happen. Another thing too is to, like, internal docs. How many companies here have internal docs? Okay, keep your hand up if they're good. All right, about half the hands went down. So this is a problem that we've had at IBM like from day one, is that writing internal docs, everybody wants to, right? So you start a project, you're leading a team, you start writing some docs, but they end up as like a wiki on the GitHub repo that's not linked from anywhere, and then you forget that it exists, and then you start a box note or a Google Doc drive or a Google Doc, and you know, the docs get really disparate and they stop lining up with each other, and nobody remembers where they are except for that one person who's like the doc overlord who has this crazy compilation note. That kind of stuff it's just very, very hard to follow. So try to find a way to get all of your teams to agree that there is a single source of truth for at least information about testing. Preferably a single source of truth for everything, but that can get hard when you've got big companies with tons and tons and tons of information. So, you know, just try to find a way to capture that information. When something comes in, when you've got a new project, if you come up against a testing edge case, don't just solve that edge case and move on. Other people will hit that edge case. Capture it. I mean, if nothing else, write a Medium post about it so that you can point your coworkers to it. Like, that's a great way to grow your eminence in the community, to help out the developer community at large, and to also get feedback. Like, one of the best things I've ever done is started writing publicly, because when I put my ideas out there, people then give me feedback and say, hey, did you know that you could make this way more efficient if you did it like this? And I did not know that. Let me adjust the post and also become a better person. These types of things are critically important. So find a way to share that information internally. And don't make it your job. If you're the senior dev, if you're the architect, you are not going to be able to heroically carry your workload and also the rest of the team. It needs to be a community. It takes a village, right? So definitely try to find a way to make those internal docs work. Also, spend time to coach the team on writing testable code. This stuff is really important. You know, writing testable code is hard, especially if you're used to working in a really kind of imperative, like spaghetti style, or if you came up like reading a lot of PHP tutorials, and so you don't have like a really consistent view of how code should work. It gets hard, you know, and that's how I came up. I came up reading PHP tutorials, and this was like in the PHP 5 days, when the community at large was a lot of people like me who didn't really understand this stuff, but they were trying. And so I developed a lot of great habits and a lot of really terrible ones. And I had to train out of those. And I did that because I had people to coach me. Some of them were open source people who were just like took the time to write this stuff up so that I could read it and become better. And some of them were senior devs who came over to me and were like, hey, you're wasting a lot of effort doing this. Did you know that it would be better if you did it like this? So make sure that you're taking the time to make your team's life easier. They're gonna make your life easier when they're writing better code. So one of the best things that I've ever learned is, you know, is everybody familiar with the idea of a 10x developer? A developer who can do 10 times the work of an average developer. If you are the 10x developer on your team, the worst thing you can do is just be a 10x developer. The best thing you can do is be a 5x developer who makes everyone else around you a 2x developer, right? That should be your goal. That's what a senior dev does. And you can be the hero, but the heroes die at their keyboards. They're up until 3 in the morning. They're getting the page at 4 a.m. You don't want to be a hero. You want to be a leader. Leaders are bringing the people around them up. So if you've got a 1x dev on your team, figure out how to make them 2x. Probably they're a 4x if you figure out how to unlock that, right? So figure out ways to multiply your team, and that coaching is going to be how you do it. And as a last resort, if you just don't have the time, talk to management, get buy-in, hire external trainers. The cost of bringing somebody in for a few days to teach your team how to train, you can hire Kent, I'm pretty sure, to come in and teach you how to write tests. The cost of that is going to pale in comparison to the cost of replacing your entire legacy code base when you don't get around to writing tests, the only guy who understands it quits, and you're 5 years down the road. This is a problem that we are actively dealing with in IBM, where we've got multiple products who were owned by 1 or 2 people who have retired or moved on to new jobs. So we have Java monoliths that no one understands, but they run, so we don't touch them. As soon as we need to update a feature, that's a full rewrite, because we don't know how it works. We're all JavaScript devs now, right? So this is something that you really, really, really want to avoid. So take the time before it's a problem. Do the training. If you need to, hire help. There are lots of very brilliant people who will happily come in and teach your team how to do it. That's how they feed themselves. They're going to make you more money. They're going to make you happier, and you're going to help them afford dinner, right? Another big thing to keep in mind, and this is probably the hardest one, executives have to be trained. If you've ever heard the term managing up, probably the most important skill that I've ever developed is the ability to manage up. You need to be able to take something deeply technical, like eliminating technical debt, or decreasing maintenance cost, or eliminating the overhead for setting up a new microservice. Things that, like, you get through half of that sentence and the executive is already going to be on their phone and ignoring you. They don't care. So how do you take low-level technical things like that and explain them in a way that makes executives go, oh shit, that's important, right? So here's a very rough framework that you can use. An untested product is very fragile, right? By its very nature, we don't know what happens if stuff goes wrong because we don't have tests for that. Fragile products are going to break in unpredictable ways and at unpredictable times. Unpredictability is going to cause delays. Now, as an executive, you know delays are the worst thing in the world because you arbitrarily promised some customer that you would get something to them by the end of next week and then let dev know afterward, right? So if something breaks unpredictably, that's going to cost a lot of money, and it's going to frustrate your customers, and it's going to make you look like you don't have control of your team. These are all extraordinarily important things to executives, right? They're measured by their ability to deliver on promises. And typically they're making those promises by pulling arbitrary amounts of time out of their ass and saying, yeah, customer, we'll get you to that. So find a way to tie things like foundational quality to the executive's deliverables. Find a way to figure out what hurts them, what causes them problems, and then communicate it in that way. And don't worry about the technical details. They don't care if you're using Jest or Mocha or whatever. They just care that once you've got a testing harness in place, your velocity is going to go through the roof. Your ability to deliver reliable code that doesn't break, that makes them look great to investors, that is the thing that matters. That's what they care about. So focus on the benefit to them. The benefit to you is implicit. If you get them to buy in, you can do whatever you want because they don't care what tech you use. So focus on their benefit and make sure that they are bought in and see that it's important. Another one that was big for us was to try to find a way to make coding, or the code quality, a point of pride in our organization. We don't want people to say, oh, I stayed up all night and I shipped it. We want people to say, I shipped that and it is rock solid. Like, it's tested, we know it works, like, we're at 100% coverage. That's awesome. You don't need to be at 100%, but you get what I'm saying. So we did a couple things. We used SonarQube here. We host it on premises because it's IBM. And we get this visual dashboard. Now, this isn't our visual dashboard. This is from the SonarQube marketing page. But it shows executives or anybody who's looking at a glance what the health of a given project is. And you get just a basic letter score. You want an A. But we can also see like in here, there is a measure of technical debt, and there's a measure of like how many bugs and vulnerabilities are in the code. These are really, really powerful metrics, right? Because if you say, oh, I don't have time to test, okay, all right, yeah, you probably don't, but you know, your stuff works. But if you say, I don't have time to test, and then I can look at this and go, yeah, but you've got like 15 security vulnerabilities, that's gonna tug at the part of a developer's pride that makes them want to be better. You know, we do this because we're competitive with ourselves. We care about what we're building. So we need to have the right metrics to inspire us to care about the right parts of the code. A dashboard like this, we're gonna want that to be straight A's, right? Like implicitly, we're gonna go, oh yeah, emotionally I need that to be straight A's. Another thing that we can do, and this is one of my favorites, you can measure the health of a repository over time. So it's not the greatest visualization, but you can see here on the third bar down, that's the coverage measurement. And if you look at the left, it started out extraordinarily low, and it just slowly crept up, and it's now just about 67%, right? Now, if you were to look at this just kind of on the surface, you might think, oh, well, this team's not very good. They've only got 67% code coverage. But then if you look at the history, you can see their technical debt is trending down, their code coverage is trending up, their duplicate code just dropped off precipitously at some point about midway through the project. All of that shows this team is actively improving the code that they're on. And this helps avoid vanity metrics like, oh yeah, we wrote a new project and it's 500 lines of code and it's got straight A's, we're the best developers in the company, you know? But okay, cool, but this is a project, I don't know how many lines of code it is, but this has been actively improving. Every single commit, more or less, has been improving the quality of this code base. This is a great team. Even if their strict metrics might not sell that. So you want to make testing a deliverable and not a nice to have. This is something that's really hard because, again, testing is not exactly customer facing. You got to be careful about that. You got to sell this to people. But the way that I like to look at it is that if you launch a new feature without tests, it's not safe. You're launching something unsafe. I'm not even going to go. That's just kind of self-evident. Like, tests need to be important. You need to, and your culture needs to shift to reflect that. So, all that being said, what happens if people fight it? What happens when developers just actively refuse? The first thing is to recognize that they're not necessarily, now there are people who will just do it because they want to be difficult, but not necessarily. A lot of people resist change because, you know, have you ever read the book, Who Moved My Cheese? It's kind of like that. We're moving their cheese. Old habits are hard to break. It's difficult to look at something and know that you've done it the same way for years and then be asked to just suddenly do it differently. That you're going to have some emotional resistance to that. Also, new requirements cause anxiety. We talked about this earlier. For a developer who's always done something a certain way, to suddenly have an additional requirement is going to make you feel like, oh, I don't have time for this. Like, you already have me on deadlines that I can't meet, and now you want me to write tests too? Like, that's not going to work. So we'll talk about that a little bit. Probably the easiest way to start making this change is to start replacing habits with good ones. If you've ever gone on a good diet, like a healthy eating kind of diet, the ones that are really effective, that really see change, are the ones that don't say, you can never eat a donut again. They're the ones that say, okay, so you can eat whatever you want, but in addition to whatever you're about to order, make sure you order a side of vegetables and eat that first. And you know, this is, I don't know if that's actually, I'm not a nutritionist, you talk to your nutritionist, but, but that's replacing a habit, right? So instead of, I order whatever I want and I eat it all, you order whatever you want, but you also order vegetables and you eat those first. And by doing that, you tend to eat less of the unhealthy stuff, which ultimately leads to healthier eating, which ultimately leads to you being, you know, in the shape you want to be, right? And so we can do the same thing with testing. We can replace bad habits, not testing, with good habits. And we can do that with things like the PR workflow, right? We can just eliminate the ability to easily do the bad thing, like force pushing, and we replace that with a workflow that is easy to follow, that does a lot of automated things, and it just kind of like, it's not additional work, it's just different work. We're replacing an old habit with a good one. Also try to understand where that resistance is coming from. You know, I already talked a little bit about how a developer who fears that maybe their skill set is not where it needs to be, getting asked to include another skill set is going to be a lot of pressure, right? So you want to make sure that you're meeting them there, that you're explaining, we don't expect you to get this today. We don't expect you to get it tomorrow. This is something that we're going to be ramping up slowly, and we're going to help you. We're going to support you along the way. Try to focus on the bright spots. When you're rolling out a new initiative, it's very easy to focus on the team that's not agreeing, that's really resistant. Try to look at all the teams that aren't. Look at all the teams that have embraced this and hold them up as great examples to the rest of the company, you know? That it causes you to reward the right behavior. So you can do things like use your testing and quality as a metric during code reviews. Publicly recognize team members who improve code. I'm going to start going a little faster because I'm just about out of time here. And if that doesn't work, if you can't get people to buy in by trying to shape the process, you can try something more extreme. One of the ways to do it, if you've got a team who's really dug their heels in, reorganize them, break them up, move them onto different teams. Because a lot of times, people will mirror the teams they're with, right? If you spend the most time with a group of 4 or 5 people who have all said, testing is stupid, we don't do that here, split them up and put each of those people on a team that is into testing, and now the 4 or 5 people they spend the most time with are testing, they're writing tests. Environmentally, that will probably psychologically nudge them to just do it. Measure management on their team's code quality. This one is, teams tend to deliver what they're measured by, right? And so if a manager is only measured by delivering a feature, the team is only going to be measured by delivering the feature. If you measure management on their ability to deliver well-tested code, suddenly the team is going to be under pressure to deliver well-tested code. Word of caution with that, make sure that when you're adding these requirements that you are factoring in the extra time it requires to make this work. If you try to pile additional requirements onto already tight deadlines, you're going to get a mutiny. Stop rewarding bad behavior. If a team stays up all night to deliver a feature and they're way over their hours and they're exhausted and they didn't test the code, that's not a good thing. Don't high-five them. Don't call them superheroes or rock stars. They're bad developers. They should be on schedule, right? Like good developers get to go home at 5 p.m. and enjoy their weekends. That's what you should be rewarding. Teams shipping feature without tests missed their deadline. That needs to be part of your core company culture. When somebody ships something, if it's not tested, it's not complete. This is also a phrase that I hear a lot. It has to be stopped. And I'm guilty of saying this myself. I'm guilty of letting teams get away with it. But if somebody says, well, we just need to get something out there and we'll add tests later, it never happens. It's not going to get done. You're going to move on to the next deadline. You're never going to revisit that old code. So whatever ships first probably ships forever. So keep that in mind and shape around that. But also be reasonable. You know, like you can't give people unreasonable expectations. You need to give them support. They're not going to go from 0 to 100% coverage in a sprint. So a couple ways that you can try to keep that reasonability going. Start plugging your leaks first. On code bases that have really low coverage, we talked about this a little bit earlier, only new code has to meet those testing requirements, right? You shouldn't have to fix the whole code base at once. And then you can create a ramp-up period where you can say maybe in the first quarter you want to add 15% code coverage, and in the next quarter you want to get it up to 30. And for some projects, maybe that's really, really conservative and they can do it much faster. And for other projects, like a 500,000 line monolith that hasn't been maintained in a while, maybe that's too aggressive. Maybe it's 5%, you know? But another thing to keep in mind is testing, you only have to go slow at first to go really fast later on. So improving that foundational quality is going to help you increase the reliability of your code. It's going to decrease the time to find and fix bugs. It's going to speed up the delivery time for new features. You're going to eliminate your existing technical debt. You're going to help prevent new debt from being created. And you're going to lower the cost of maintenance. This is a huge, huge list. And this list speaks to everybody. It makes your customers happy. It makes executives happy. It makes managers happy, devs happy. Everybody wins on this list. So really quickly, let's do a recap here, and I'm going to give you action steps. So to create quality-driven culture in your company, oh my God, I'm so out of time. First, make the right thing the easy thing. Provide support and ramp up time for your developers. Convince management to make time for quality. Reward desired behavior and stop rewarding bad behavior. Automate as much of the process as humanly possible. And take pride in shipping quality, not just shipping. Because remember, it doesn't matter if we're shipping every day, if we're shipping shit. So don't ship shit. Testing is a supercharger for your company. It's, we've talked about this whole presentation has been around this. It is slow and difficult to get the mindset in place, and it's going to take time, and it's going to take effort, and it's going to take more than just one person. You have to build a culture around it and let that culture grow. But once you get started, it makes your company completely unstoppable. Thank you very much.